Hey guys, let's talk about the probability of an event. So the probability that an event occurs is the measure of the likelihood of that event happening, okay? So the probability of an event occurring is a number between 0 and 1. 0 means that it will never happen, and 1 means like it's going to for sure happen, okay? It's inevitable. So if all the possible outcomes of a probability experiments are equally likely to occur, then we're just going to use, what happened there? We're going to use the classical method to compute the probability. So here is that. We're going to use P of A equals N of A over N of S. Here's what that breaks down to be. P of A represents the probability of an event event A occurring, and N of A is the number of outcomes in the event, and N of S is the number of outcomes in your sample space, okay? So here's a good example. If we have just a regular deck of cards that has 52 cards in it, there are 4 aces in that deck of cards, right? So if we shuffle the deck of cards and pick a card at random, we're going to let A be the event that that card is an ace. Now since there are 4 aces in the deck, N of A is going to be 4. So 4 is what we put on top. Now the sample space we know consists of 52 cards. So he goes on the bottom. So it's going to be 4 over 52, which simplifies to 1 over 13. Okay, and this is super important, so I'm going to put some little asterisks right here. Always be sure to simplify your fraction to the lowest term. Okay, you do a lot of work to get to that point, and I don't want you to miss any points just because you don't simplify your fraction. Okay, let's work smart, smarter, not harder. So our first example here is that we're going to roll a 6-sided die. I'm so sorry, guys, I'm losing my voice. Find the probability that the roll is even. So we know that there are 6 possible solutions, right? When we roll a die, there's 6 sides, and then 3 of those sides are even. So our fraction is going to be 3 over 6. We're going to simplify that to 1/2. Okay. Now, normally I'm just going to turn you loose with this, but there's one that I remember. Actually, I had done this video before, and then I was like, oh yeah, that's one that's kind of tricky, right? This one is just exactly like the example problem, and so, or number 1 is, and number 2 is not much different, but number 3 is, it's kind of different, and 4, so I kind of wanted to work it, so you have some idea how to do it, because I don't want you to be frustrated and be like, oh my god, this is so weird. I don't know how to do it. So let's do one together, and then I think if I do 3, I think you'll be able to do 4, and then you'll be home safe on these, okay? So it says a jar contains 50 red marbles, 20 green marbles, and 10 blue marbles. If a marble is selected at random, find the probability that the marble is green. Okay, so here it goes. So what we do to find, I'm sorry, my throat is getting worse and worse. N of S, let's add all of our marbles, right? Let's put all of our marbles in one basket. So, so our sample set is going to be 50 plus 20 plus 10. So that's going to give us S is 80. Cool. And then what we're looking for is we're looking for the green. So that's going to be our N of A. And our green, if you'll remember, was 20. So our P of A, no, our N, I'm sorry, of A is going to be 20. This is our, I should have done that the same color. US. Wow. Now my computer decides to mess up. So anyway, we're going to have 20 over 80. And then, of course, we're going to simplify that, right? And it's going to be 1/4. So that is our, equals our P of A. Okay? So I think from that example, then you could probably figure out 4 and then just rock it on out. Okay, guys. Have the very best day.